We're looking at a special case when it comes to two-dimensional elastic collision. So here we are considering the masses m1 and m2 to be equal to each other, and let's call it as m. So that's the special case. Okay, first we start off with, so what is the final, what happens over here when this is the case? That's what we're looking at. So basically we'll start off by considering kinetic energy of the system. So since it's conserved, so kinetic energy initial has to be equal to kinetic energy final, right? So half m u square should be equal to half m v1 square plus half m v2 square. So m and half will cancel each other. So you have u square is equal to v1 square plus v2 square. Okay, that's well and good. Then by conservation of momentum, we know that the initial momentum should be equal to the final momentum. So here m and m is common. So we have the following. I'll call this as 1. So with these two results, we'll be able to conclude one thing. Let's look at it. So taking 1 dot product between equation 1 with itself. So this is dot product. So you have u1 dotted with u1. So that will give us u1. And we have v1, u1, v2. Actually, we'll get square and stuff, but yeah, let me just finish this. Okay, guys. So what is u1 dot u1? Yes, u1 square. And then v1 dotted with v1 will be v1 square plus v1 dotted with v2, then plus v2 dotted with v1. So these two results are equal, plus v2 square. Okay, but u1 is equal to v1 square plus v2 square. So this I'll call it as 2. So from 2, you have u1 square is equal to v1 square plus v2 square. So we have this entire expression getting cancelled. So we have we end up with 2v1 dotted with v2. Remember, dot product of two quantities, the order does not matter. So these are equal. Right, since it's a scalar quantity, they are equal. So this is nothing but 2v1 v2 cos of theta 1 plus theta 2. Right, theta 1 plus theta 2. Okay, so how did I get theta 1 plus theta 2? That's the angle between your v1 and v2. So that's from the figure. Okay, so if you want, you can write from figure. So as v1 and v2 cannot be equal to 0, they can't be. What we have is theta 1 plus theta 2 has to be equal to, or cos of theta 1 plus theta 2 has to be equal to 0. Okay, since this is equal to 0, theta 1 plus theta 2 should be equal to cos inverse of 0 is 90 degree. And so basically this is a result. So post collision, they will be perpendicular to each other. Okay guys, that's your proof, as in that's your result. So when we have two objects colliding, so post the collision, the angle between them will be equal to 90 degree. Okay, so that you can, yeah, this you guys can copy now.